Hi everyone. Today we are going to discuss a new topic that is linked list. Linked list can be defined as a sequential collection of nodes or objects at random locations in the computer memory. As we have discussed that linked list is a collection of nodes. Then first of all we have to understand that what is node. We can say that node is a group of two elements. That is first part is data and the second part is the pointer to the next node. This is a node, and in node this is the data part and it is the pointer for next node. Here the another node will be connected, and in this manner the linked list is grows. So your question will be that why we should use linked list and what are the benefits of using linked list. Linked list is the first step in learning data structures because it is the base of any data structure. Or we can say that linked list is a important sequential data structure in which we store the elements in the sequential form. Then we will learn that what are the uses of linked list and why we should use it. So the main advantages of using the linked list. The first advantage is it is it stores the elements at random locations in the memory. So this is so there is no limit, there is no foundation for declaring the size of the linked list. The first advantage is the storage of data at second advantage is that it is a dynamic in nature. That means we can grow or shrink its size depending upon the usability. So can grow and shrink as per requirements. And the third one is that we can we can add or we can add or remove or can update the elements in the linked list at runtime. So it is dynamic in nature. To access or to insert or delete the elements in the linked list is easier. Elements in linked list is easy. And as we all know, that if anything has advantages, then it also has some disadvantages too. So we have discussed the advantages of linked list. Now we will discuss the disadvantages of linked list. The first disadvantage is that we have for accessing or traversing the for accessing or deleting any element in the linked list, we have to access all the previous elements of it. So it takes much more time as compared to arrays. So we can see that accessing or traversing is much costly as compared to arrays. Access elements at particular locations is much costly as compared to in arrays. And the second disadvantage is, as we have discussed the structure of the linked list, that it is a collection of nodes, and each node contains two parts. First is data, and the second one is the pointer to next node. The second disadvantage is that it consumes extra space for storing the pointer. While in case of arrays, there is no need of extra space. So the second disadvantage is it costs some space, more space as compared to the arrays. So we can say that it takes more or extra space to store pointers to next node. Before proceeding with linked list, we also have to discuss about the arrays also. We should also discuss the difference between the linked list and arrays. Why should we use linked list over arrays? So the main disadvantages of linked list and the advantages of arrays we will discuss here. We will write in two parts. It's a linked list and here arrays. We will discuss the differences of linked list and arrays. In linked list, the objects or the nodes are stored at random locations, not at contiguous memory locations. And in arrays, the the data should be stored in a contiguous memory location. The second difference is based on the space complexity of linked list and arrays. The linked list takes extra space to store pointer. pointers to next node. While in arrays there is no need for the pointers, so it is space friendly, we can say. The size of the linked list is dynamic, or we can say that the size of linked list is not fixed, or we should not have, or we do not have a need to declare the size of the linked list in advance. So no need to define the size of linked list in advance. But in case of arrays, we have to define the size of the array in advance. Size should be declared or defined in advance. Next is in linked list we can modify or update the elements at runtime. Or we can say that it is dynamic in nature, but arrays are not dynamic in nature. They are static. If we insert or delete any element between the linked list, then it is easier as compared to arrays. In arrays, if we want to delete or insert any element in between the array, then it is quite complex because we have to shift all the other elements. So it takes a little more time. So it's a quite complex process in arrays. There are multiple differences in linked list and arrays, and now we are discussing only the 5 points. Before proceeding further, we have to discuss the time complexities in linked list. The time complexity for various operations in linked list we are going to discuss here. Time complexity for different operations in linked list. Here we are writing the worst, average, complexity, and here the worst complexity. For accessing, the complexity is big of n, and for deletion or insertion, for accessing big of n, and for searching it's big of n. Searching complexity is big of n, and for insertion it is big of 1, and for deletion it's big of 1, and for traversal it's big of n. And in worst complexity for accessing the element it's big of n, for searching it's big of n, and for traversal it's big of n, and for insertion it's big of 1, and for deletion it's big of 1. As we can say that the average complexity and worst complexity of linked list are same. As for accessing, in average complexity and worst complexity both are big of n, and for searching both are big of n, for traversal both are big of n, and for insertion and deletion the average complexity and worst complexity are constant. That's big of 1. Now we have already discussed the structure of the linked list. Then let's discuss it once again. Linked list is, as we discussed, is a collection of nodes. Then it is the node.